Well, this is very quiet here.
Well, I'd say something profound, but I'm afraid I'd run out of stuff to talk about by the time it was time to present.
Okay, I thought lost my audio.
Hear you fine,
No,
Dave.
we're here.
Just being silent.
Well, Stan doesn't know where all the buttons are. Stan was muted.
I know.
That's what happened to Stan. I thought there was a reason we didn't hear him.
Yeah, 31. Okay, 6:31 p.m. March 18th, Thursday. Wonderful day of the month because we have a St. Louis Linux Users Group meeting. Yay!
All right.
See.
Anybody seen Gary yet?
I talked to him earlier. He said he'd be here, but as usual, not on time. I asked him if he's going to be early, and he said no. I asked if he was going to be on time. He said he didn't know.
Yeah,
He
we
was working.
might have 95 degrees and full sunshine tomorrow too, but it's not a very high probability.
That's right. It was about 11:30. I was talking to him. He was concerned about finding lunch. So
Finding lunch. Well,
yeah, because if he doesn't start checking about 11:30, he doesn't get lunch until about 1:30 or 2. Okay. Anna. Ooh, I wonder which Anna that might be.
you can always ask, Stan.
Yes, Anna. Which Anna is this? Is it our beloved Anna from years ago that moved off towards Kansas City and broke all our hearts?
All right, you don't have to lay it on so thick.
All right. Yeah. Well, at least she kept us civil, you know. Me, I have to rely on the mute button, and I don't always remember to use the mute button. But oh my.
Anna Olson, Ghost from the Past.
Yeah.
In the chat, Stan.
Oh, okay. Cool. We have a button for that too. Ooh. Yes.
Oh, we gotta get somebody else. We're lucky 13 now.
Yeah. Hmm. Did I spell it right? Oh, no, I didn't. OHL.
There he is.
Only 4 minutes late.
Hey, Gary. You just missed Anna Olson. She was here just a minute ago. She's going to try to reconnect again.
You said a ghost?
Hmm? She said a ghost. She's not a ghost. We are recording now.
I don't know, at the rate that Zoom is making technological improvements, they might have been able to reach the other side by now.
I would think so. Okay, Norm. Yay. Well, I'm not up to running this meeting tonight. I tell you that. I'm off in left field. I can tell that. I just came back in from grocery shopping, and that really took
Stress.
my wind.
Yeah, it's really stressful.
Oh yeah. Green beans or green peas? Green beans or green peas? Oh, and there's pork and beans. Oh. So I bought a half a case of each.
Gary, I
Hey.
believe you're on mute there. I see your lips moving, but nothing actually was reaching us.
There he is.
There we go. Sorry about that. Okay.
Look more like Santa Claus every day.
Ho, 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 ho.
That's the gray. I'm referring to the gray.
Yeah. It is getting grayer all the time. So, all righty. So this is Wednesday, 18 March, 2021. It's the St. Louis LUG meeting, Linux Users Group.
It's actually Thursday, 19 February.
Thursday, 19 February.
No, it's Thursday, 18. Never mind.
Thursday, 18 March. There we go.
Yeah.
Between the two of us, somewhere we'll get a date. Dave, thank your wife. I mean, we're all hungry, and that looks marvelous. Thank you, Dave. Tell her thank you.
I better turn off the video.
Yep.
Oh my. Let's see. Announcements. Let's see. Do we have any announcements? Lee, Stan?
I got coffee. Hey, Patty, could you make me a cup of coffee?
Oh, we get our second shot in 10 days.
Hey, all right. Yeehaw.
Of course, we had to drive 2 hours to get it.
Oh my gosh. Where'd you go?
Shit, I don't remember. It's north of Salisbury, no, north of Columbia.
Okay.
But at least we found a good restaurant for lunch called Como's.
Oh, there we go.
Yeah. I'm honestly considering getting the shot in maybe August or September. I don't know.
You can't go back to an in-person meeting until you have it.
Won't bother me any.
Okay. Well, let's see. In other announcements, anything of interest? Let's see. I guess a number of folks, especially our steering committee people, have paid close attention to the libraries and whether or not there's anything scheduled where we could get physical meeting space again. As Stan and Lee were just pointing out, we're really not ready to worry about the physical meeting space anyway because of the virus still not being under control. However, the library did start doing openings just for walk-in business, use of the computer, stuff like that. So we're getting closer. Things are looking a little bit better. So, let's see. Lee, you got the calendar handy?
I can put it up. Give me 1 second.
All right.
Let's see. Where am I going here?
While Lee does that, largely thanks to Stan and also help from Phil Bunch and also Ed Howland. The Slack meeting, St. Louis Area Computer Club, and the new users lug have both been going very, very well all through the pandemic, not having their library to meet at, but they've been doing a great job of meeting online. So thank you to all of them. And okay, there's the calendar. I'm going to point out a really weird one. So go back up to the top, Lee. The 2nd of March, the 230th anniversary. You don't see too many 230th anniversary in our field, right? Yeah. But this actually was the beginning of long distance communications, the telegraph, not the electric one, but rather a semaphore system. It was actually a system of not flags, but little paddles, symbols, or whatever they mounted on towers across Paris or across France. And it got replaced when the electrical telegraph came out, but apparently it really changed things. So we don't think of 230 years ago, as being the age of communications, but yeah, it actually was a big innovation of how to transmit stuff long distances. So yeah, we're not as special and advanced as we sometimes like to think. So let's see. Other things, also in old communication, it's I believe April the 26th is the 100th anniversary of the first radio station west of the Mississippi, second radio station in the United States. It started down at St. Louis U. It's still on the air. It's WEW radio. And so kind of.
You said it's 26.
26th. There it is. There it is. So anyway,
There you go.
I haven't gotten anything done as far as organizing any celebration. If anybody else wants to help work on it, I don't know if anybody else at the university or the city is doing anything, but it should be a significant historical marker. With that, there's a whole bunch of anniversary dates. I don't know what it is about February and March, but it just seemed like February, March, April is a lot of history in the world of computing. So odds and ends you can find out there.
That's because it's too cold to do anything else.
Too cold. That's it. You're right. You're right. So let's see. Interesting conversation with Andrew at his meeting at the CIALUG last night. He was pointing out that you know, for CIA, they're getting a lot of attendees from out of state, sometimes out of the country, and so yeah, even though we keep calling ourselves LUGs, local user groups, we're the age of COVID has brought us all networked a lot closer. So so yeah, some of the things you'll see on our calendar, we used to only put local stuff on the calendar, but now a number of the entries on there are national or even international events. So yeah, keep your eye peeled. If anybody sees anything that's interesting, either ask us to put it on there, or if you want to point it out now, you certainly can. So,
How about getting a volunteer to put it on there so you don't have to do it and I don't have to do it?
Dan, that's true. As Stan says, our old fingers are getting tired. So any additional help, just doing simple things. You don't have to come to meetings. You don't have to, do a whole lot of paperwork. But just little things like somebody to help keep the calendar up to date, somebody to help get the newsletter or the weekly announcements and meetings out. So all these little things could help. So anybody interested, tug on my sleeve or Stan's sleeve, Lee's sleeve, somebody's sleeve, and we'll try and help get you organized. So.
Let me ask the obvious questions. The events that go onto the calendar, the input for those events come from where?
A number of different places. Yes, we have unapologetic.
We steal them from everywhere.
We do. We've taken it from Meetup when it looks like the meeting is something that might be appropriate for our group. Some of us have subscriptions to different organizations. For instance, a lot of the GIS mapping things, a lot of that stuff is coming now from the United States Geospatial Foundation, and basically I'm on their mailing list. And so if I get a notice of one of their meetings and it looks like something that's of interest, I'll put it out there on the calendar.
Well, then it sounds like you're the only one who can do it because it's all showing up in your inbox.
Well, two different things there. I mean, first off, the only reason I showed up in my inbox is because it was something I was interested in. There's stuff that shows up in Stan's inbox. Yeah, we'll certainly, some of it we actually send to a mailing address called editor. And, so if it goes to the editor mail, then anybody who's on the editor mailing list can see it and make use of it.
And if I create something and Gary comes along a week before and confirms that the meeting is still going on, it picks up his identity.
Ah, okay. Okay. Let's see.
And if you volunteer, it could have your identity on it too. And you get the choice of what you put on there. Unless there's great screaming and gnashing of teeth, we don't really object too much. Although Stan gets real cranky about how the thing's laid out sometimes.
And our usual way of dealing with this is it's not the crankiness that wins, but he who does the work usually gets to make the final call, and may get some suggestions, but usually sticks with whatever.
Phil Bunch, Robert Hanson, and Steve Stegman have joined us.
Ah, great. Great. Welcome, guys. So,
Hey.
Let's see.
Sorry I was late. I was out.
Anna Olson was in earlier and was promised to come back when she got some kind of software change.
Great.
This is Bob Hanson testing my mic. Am I coming through okay?
Yes, you are, Bob.
Yeah.
Thank you. I'll put myself
Oh
on.
my God. Gary that never ceases to scare me. You look like the great snow monster. Exactly. In one of those kid cartoons that my grandson watches.
Looks like one of the trees out of The Hobbit.
Yes.
Yeah. They do talk, don't they?
Oh, yes. All righty. Well, let's see. Are there any other announcements, suggestions, admonitions? Hearing none. I do have our topic tonight is Kubernetes related, largely Kubernetes, and I've been talking to another presenter, and so we may have another Kubernetes talk next month, the following month, but it's in the works, and it's one that's very much tailored to the specifics of Kubernetes and Linux. So that may be coming up. Watch the announcements, and we'll see. With that,
I'd like to point out, if you don't like our agenda, you can always volunteer to do something.
yeah, that's true too.
Hint, hint, hint.
Yep. And we'll even take suggestions for topics. I mean, if you've got an idea for a topic, but you don't want to speak about it, and you don't know a speaker, we'll at least welcome the suggestion. That'll give us something to look for. So,
Although we probably already have about 80 suggestions that nobody will do.
that was one of the things Stan and I talked about. Is maybe next month we'll bring that list in and post that up during the Q&A or the announcements beforehand here, just to see if anybody wants to suggest a speaker on any of those topics. With that, general Q&A. Anybody got any technical questions they would like to ask?
I do.
Yes, Ed.
Okay, well, Phil and I were batting this one around yesterday, and after we got done talking, I went and looked it up on Google, and I could not find a good answer for this. So we've done a little bit of research, but I'm not quite sure. So there's three things in Linux that have to do with packet filtering, firewalls, such as there was IP tables, and I understand there's a new one called NF tables. I've never heard of that in my entire life. And then there's eBPF, which is the Extended Berkeley Packet Filter, which showed up recently in the kernel. And I'd like to know if anybody here is like, maybe our presenter tonight maybe has something to do with this. I'd like to know whether or not they're, related to each other, like one supersedes the other, right? Are they all like running on top of eBPF? Like, what's going on?
Ed, DistroWatch had a discussion about IP tables and NF tables and a bunch of other stuff just this week. So it's in their weekly roundup thing.
Yes, that's what we were talking about, but they don't, I wanted to know what's the relationship between that and BPF, right? Because BPF is like very low level, kernel level stuff.
Could you spell that phonetically for me? I'm not quite hearing what you're
Well,
saying.
it's actually eBPF, so Echo, Bravo, Papa, Foxtrot.
Thank you.
Extended Berkeley Packet Filter.
Never heard of it.
Ah, crickets.
Yeah.
It's a virtual machine that's running inside the kernel. And you compile code. I think it's written in like a dialect of C or maybe Python. I'm not sure which one. But it compiles down to this bytecode that runs in the kernel and basically hooks into like all the places where events in the kernel can occur, such as an incoming packet or a route of a packet to another place or something like that, or outgoing packets.
So I just posted a article from 2018 that would seem to indicate that basically eBPF, if I can say it right, the BPF is basically taking and superseding IP tables and everything else because it was higher performance.
Right.
Since it's lower
yeah,
level.
I had read that article from the one you're talking about from 2018, and I just wanted something newer. But there was like, you know, any newer updates to that.
The most I know about it was a couple months ago. There was someone up at Central Iowa that gave a presentation about doing things using it, if I remember right. I'll see if I can't find the video for that.
Oh, okay. I'd be interested in that. Thanks.
If eBPF is in the kernel and the Berkeley kernel is different from the Linux kernel, is it going to work on Linux?
It was ported from the Berkeley stuff to the Linux kernel. It was in, I think there was an experimental version in the 4.x kernel, and then I think they made it official in the 5.x kernel. If the chronology I read in that article was right. Berkeley is just the name. I think it's like it was like a Unix thing that was developed at Berkeley. I don't know that it was necessarily part of BSD, but it probably is in BSD for all I know.
Well, actually, PF's been around for about 15 years. It started with OpenBSD, and it was originally one of their projects. I don't know if the Linux version is a fork or just an integration. But I built a few of them around here for our OpenBSD boxes. It's actually pretty nice compared to IP tables.
Yeah, it's certainly a lot more extensible, or more low level too.
Well, it's basically IP tables with a English front end on it. Let's put it that way. You know, you can define a logical structure. You can have variables. You can have tables. You can have traffic rules. And it's literally an order of magnitude more readable than trying to write your IP tables, much less trying to dig through IP tables that are already created in the kernel with all kinds of cruft that isn't applicable.
So I guess my original question was, if you have that built into the kernel, does IP tables and NF tables just act as front ends to that, or are they like completely separate?
I understand the question, but I don't know the answer because all three are ways to manipulate the routing tables in the kernel. And my assumption is they're all various ways to perform that job, although I have no idea what would happen if you tried to use two of them to tweak your routing table. In other words,
right, you're routing the same address with two different mechanisms. Like IP
Well, yes,
tables doing it one way and BPF doing it the other way.
Well, the way of doing it is particular to the tool you're using. The IP tables tool has one syntax. The other one you mentioned probably is similar, and then PF is a much simpler English style syntax to use. No matter what you use, the basic routing table in the kernel is just the routing table in the kernel. So however you create that routing table, you probably have I think you probably have an API that each of those particular application uses to build it.
Okay.
So the fact that PF is in the kernel doesn't really mean that PF is in the kernel, but they added the API so that PF could manipulate the rules that the kernel or that are actually in the kernel for real-time traffic control.
So does the BSD, the OpenBSD packet filter or PF, does that compile down to a bytecode virtual machine?
No, when you run it, it creates the routing table for the kernel.
Okay. Well, the one that's in the Linux kernel, eBPF, is a bytecode virtual machine that runs in kernel space.
Okay, so that's different than what I was thinking.
Yeah, I think these names are very similar. And with the Berkeley in there and packet filter in there, right? Like, which are we talking about, right?
Well, it could be both, because you couldn't call it packet filter if it didn't use the language that you have from packet filter. So maybe that's the packet filter front end on a different back end.
That's a possibility. I was just hoping somebody was more knowledgeable, or I mean, that had direct knowledge of the relationship between them.
Doesn't sound like it. All right, Gary, back to you. Anybody else?
But it does sound intriguing. So yeah, any other questions? More comments?
Oh, a quickie. Has anybody gotten RDP to XRDP to work on a current kernel?
I was able to get it in the latest version of Ubuntu, but I don't know which kernel it's actually running.
Okay, well, what window manager did you use? VNC, RDP, X, you know?
My bet would be X, because I doubt Wayland would play nice with that.
Okay, back up. The XRDP configurator that I've been working with has 3 options: VNC, Xorg, and something else. In fact, at the guacamole presentation last night, I realized that it doesn't make any difference using guacamole, because it has to talk to the API to provide the remote window. So if I can't get XRDP working, guacamole doesn't do any good. And if I can get it working, then it solves the problem. I think in my case, there's an issue that XRDP isn't hooking the right session manager. But I can't figure out a way to debug it. Anyway, next question. Well, since it's 7 o'clock, Gary, maybe we ought to. Oh, is somebody gonna? Dave, you can say something?
There's a new person, Dave Chellai, that's joined the room. I wonder if he had any questions.
Oh, no. Hi, thanks. This is Dave Cayley. I'm in St. Louis. This is my first meeting. Interested in the Kubernetes. I'm not a sysadmin. I'm more a developer and manager, and been working with Unix and Linux for quite some time. Not an expert, but it's just something I've always enjoyed my whole career.
Okay.
Welcome.
Always welcome to come to the meetings.
Well, thank you very much.
Oh, with no further questions, Gary, maybe we ought to introduce our guest speaker for tonight.
I think so. All righty. Our speaker this evening, and he's been here before, is Andrew Denner. In his day job, Andrew is a senior scientific software developer at Pioneer Grains, or the name of the company may have changed since then, but Andrew can tell us if the company name is different. And of course, by night, he puts on his cape and cowl, and he runs the CIA. Oh, that's the CIALUG, the Central Illinois. I'm sorry, Central Iowa. What's the A?
Central Iowa IA is the abbreviation.
For Iowa.
Yeah, IA is just the abbreviation for Iowa.
Yeah, it's a bit of a stretch, but the name works.
It works. It keeps people interested. The CIA has a lug. So, but Andrew does some wonderful talks up there running his organization, and he was nice enough to come and reprise one of them with us here this evening. So with that, I'm going to turn it over to Andrew.
Thank you. Yeah, hopefully this time it goes a little bit better than the last time I gave this talk. Ended up forgetting to clear out my Kubernetes configs, and it basically crashed and train wrecked, and we had a great presentation on how to debug Kubernetes problems sort of on the fly. So let me hit share here. Okay. So the first, before I dive into my presentation, I did see on Hacker News this morning an article about using Kubernetes to run somebody's personal blog, and the Twitter photo they had there just was great, of that little tiny thing on this huge flatbed. So a little bit of humor to start out with, I guess. Let's see here. Hopefully everyone can see my screen here.
Yep.
Hey, Andrew,
Okay.
quick question.
Yes.
Is the slide deck for this going to be available?
Yes, I just posted a link to it in the chat, and then I'll also email it to the editor group here afterwards.
Fantastic. Thank you.
But so the working title of this was Local Kubernetes for Dummies, aka me. Or so you want to move up from Docker Compose and start using the same tools across everything. As they pointed out, I do software development for a company now is known as Corteva, used to be Pioneer. And otherwise, we also have some fun with the Linux users group up here in Iowa. So just to sort of set the level and make sure everyone's all on the same page, why do we care about virtual machines, Docker, and all of this stuff? Well, because for the most part, your big servers in your data center are huge, and they're good at running a lot of things all at once and sharing, but things don't also cooperate very well, and people end up getting peanut butter in your jelly, and apps clash, versions of Python are a nightmare, etc. So the first sort of granddaddy of them all are VMs or virtual machines. Those are like your VMware or your Zen or your Hyper-V, KVM, or stuff like that. And basically, the way to think of that is you have your bare metal, then you have a thin host OS or hypervisor, and then each VM has its own full-blown OS, its own kernel, all of its own libraries. There's not any bit of sharing going on, which is great because you don't have to worry about, okay, what kernel, am I running Windows, am I running Linux, all of those things. It doesn't matter. But it also is very heavy. And there's a cost to that in both CPU usage and memory, because you don't have very much sharing going on. But it does give you a lot more security in that it's full isolation. The other option is containers. LXC is the granddaddy of them all. Docker sort of came on the scene and was the most popular. And then there's also other stuff. The container, or the Cloud Native Container Foundation sort of is taken over sort of arbitrating everything. You've got Podman, all of those sort of things. And the way to think about this is you've moved up the ladder a little bit. You're sharing the host OS, all of the infrastructure, and then there's a manager that runs, that's your Docker host and stuff like that. And then really all you're actually inside of this container, you're just running your app and some shared binaries and libraries and stuff like that. And it's really nice, light and fast. It gives you near native performance. You do have process level isolation. One of the biggest problems though is that Docker daemon is running as root. There is something that's called rootless Docker, and it works great. There are, of course, strings attached with that too. But that way, if you escape, you're not going to actually be in God mode there, basically. And one of the biggest benefits to Docker over, like, say, LXC is that there's a container repository. So I don't have to build my own bespoke custom WordPress web server, because someone's already done the work for me. And usually they're probably more clever than me, because usually it's the guy who wrote it or someone who's intimately more familiar with it. So it sort of serves as a force multiplier. I don't have to worry about, okay, now I have to download the ISO, now I have to go through all the steps of installing and all of that hand rolling stuff. You still can, or you can run it basically just bare metal, just build the bare bins and libraries that you need. But for the most part, only crazy people or people who care about security and stuff like that deal with that. So the great quote from Amazon: Docker's a software platform, lets you build, test, deploy applications. They're in containers that are just sort of a standardized unit. And the way that I think about it is it solves the question of, well, did the application run on my machine? Well, the thing I handed to you is basically the de facto machine. So I know that handing you my container, it will work for you too. And it really is a huge ecosystem. There's a lot of different pieces and parts and all sorts of stuff, and you can drive yourself crazy trying to keep track of all of this. There's a year worth of presentations just on this slide alone if you went and dove into everything, just even in which container DShims you're using, whether it's Firecracker, which is Amazon's Lambda, Run C, which is the cloud native one, the Windows, etc. You could just go crazy on this screen. But of course, there are drawbacks as well. One of the biggest problems is with Docker, you're spinning up and running individual images or containers. So if you want to do it right, you really want to have your database server isolated and your web server isolated and your Kafka system isolated. And the problem is, now you have to spin up one, then you have to spin up the other, getting the networking right. It's just a nightmare. And that sort of leads into the networking problem, especially if you have multiple Docker hosts. Well, okay, how do you network between them? It's just a ball of wires here, as you can see. And in the end, your Docker host that you're running your image on, it's still just one machine. So you've shifted the snowflake down. So instead of your container being the snowflake, well, the host that it's running on is your point of failure. And eventually, you end up needing a bigger boat. You have enough containers running, you can only build a server so big, and your pocketbook's only so big, so you're gonna need a bigger boat. Thankfully though, this has been a solved problem. It's not something that you really have to worry about anymore. There's Kubernetes, or the other competing option is Docker Compose, and that solves some of your problems. Basically, you can create a YAML file that basically describes all of the different containers you want to orchestrate together at once. The only problem is there's really no repository. There's a bunch of like GitLab stuff out there or GitHub that you can go copy and paste, but you're still rolling your own YAML. And I mean, it's easy, YAML's easy enough, but I always get it wrong. YAML without fail, I always have to throw it into a linter because I have the tabs wrong or something, etc. And by default, you're still on one machine. This isn't necessarily 100% true because apparently, at least according to the one link I found, they've extended it to be able to work on Kubernetes as well. I haven't tried that though. And here's an example of what the files look like. For example, this is a Docker file that we're spinning up a .NET window or .NET Blazor application, and then basically compiling out the WSAM, and then we're hosting it. And as you can see here, we've got a Caddy web server serving as the reverse proxy. We've got a Postgres server, and let's see, other interesting stuff here. We've got that web server that's being hosted out, and then a MySQL server, and etc. So, I mean, as you can see, it's fairly easy to orchestrate, but if the data center catches on fire over in Germany, you know, my server's down and it's dead.
Oh, Andrew, how am I going to get that black magic marker off my screen? Actually, that is it. Oh, good.
Yeah, there are ways of doing secret storage and hiding it better than just chucking it in as environmental variables. But, you know, this really isn't production code, and it was only running locally, so I really wasn't too worried about it. But rest assured that there are about 16 characters of random password there. And it's not just my super secret password. Although initially it was.
And when you were describing the Docker file on the right, you'd mentioned the acronym WASM.
Yes, WebAssembly. Basically, a little out of scope here for this, but essentially Microsoft.NET now has a version of .NET that can run in your web browser. And so it can run essentially a single page web app running inside your browser as a JavaScript-like low-level bare metal application. And the goofy thing with that, it's really quite cool in the fact that they wrote the .NET missile, basically the code that runs the .NET assembly code and compiles it into your local machine code. They wrote that in WSAM, and you end up downloading your DLLs and executing the .NET code in your browser. There's still some rough edges in it, but it's a great way of being able to share front end and back end code if you're a C# developer.
Wow. Okay.
And it really just truly came out in .NET 5, really production wise.
Okay.
But you were saying there, sorry?
I said, or a Rust developer.
Yes. However, I do want to call out the fact that it is actually open source now, so it does sort of fall under the free and open source umbrella. So Microsoft, the times are changing. It still makes you feel a little dirty deep down inside, but it was something I wanted to try out and see how well it worked, and it wasn't terrible. There's still some really rough edges, but it was kind of fun. Continuing on though, another option to sort of solve that one machine single point of failure, there's something called Docker Swarm, and basically it's a fleet or a swarm of individual Docker hosts that are all networked together. and it's fairly simple to set up. It's supported inside of Docker. You use your same Docker commands that you use to deploy containers, and it's great for the fact that it's easy. Eventually, you'll hit the wall though, where the easy won't handle the cases that you need. In my case, the stuff I was playing with was eventually going to be deployed to a Kubernetes cluster anyway. So I figured you might as well, rather than figuring out how to get it all working and then still have to change everything to get over to Kubernetes, there wasn't much point in it for me. Also, but I do want to say that deep down in my heart of hearts, I really do like Docker Swarm. It's elegant, it's fun, it's cool. And that also means that it's going to be the industry loser. Without fail, if I like a technology, usually it means that I really shouldn't get my hopes up, because it's going to be the one that loses. I mean, Betamax, awesome. Never mind. But so really the way that the industry has been moving is towards Kubernetes. So it's better just to sort of embrace the world, I guess. And so that brings us to Kubernetes. You've probably noticed I've used the K8s abbreviation a few times for it. Why K8s? Well, because there's 8 letters in Kubernetes between the K and the S. It's clever, I know. Anyway, though, it's Greek for helmsman. It's originally started in Google in about 2014, and one of the big benefits to it is you can't build a cluster big enough, probably with your budget that you have in your pocket, that will be too big for it. They call it planet scale. And essentially think of it as Docker Compose in the fact that you can do all the orchestration, but it's large. It handles all of the orchestration. It handles wiring and figuring out, okay, I know that my one container is running over here, the other one's here. Oh, there we go, running over here. Okay, how do I network between them? Okay, I need 6 gigs of RAM. This one needs 2 gigs of RAM, and it needs to be running on a machine with the GPU. It handles all of that. And oh, this host over here just died. Well, that's okay. It will start everything back up over there. It also handles secret management and industries. You could spend a whole long time talking about all of the different things that you can roll with this. It also does mean that it's insanely complicated, and the batteries definitely aren't included by default.
Hey, Andrew.
Yes.
I know this is like a minor part, but I appreciate you bringing up the K8s. Somebody literally just emailed me about my K8s. I'm like, I don't even know what you're talking about. Now I do. So thanks.
Oh, it gets even more fun, because when we get to K3S, there's a great funny story behind that.
All right.
Anyway, though, like I said, batteries are not included. There are rough, ugly edges, and you pretty much, if you want to build a Kubernetes cluster from scratch, it's kind of like rolling your own Linux distro from scratch. You can do it. It's gonna suck though. So the big things to remember: it's not a drop-in replacement. The commands are different. You've got kubectl is your biggest one. And there's no real limits. You can run services, you can run batch jobs, you can schedule cron tasks to run, etc. And it is not a CI/CD process, although you can run it inside there. There's also no middleware, message bus, etc. But hey, that's just another container to run in there. And like I said, it's really hard to set up by default. And so just as some architecture here, you'll, yes.
On that first bullet, you mentioned, was it kubebus?
Kubectl, KUBECTL. Basically Kubernetes control. We'll cover it here in a minute here.
Okay.
But basically just think of it as like your Docker command where you're launching things into the cluster. But so big things to call out here. You've got a control plane that's basically running and orchestrating things. And then you've got multiple lesser nodes that listen to the control plane for directions. Tonight, we're just going to have them all running on one machine, which will also cause a little bit of heartburn for us here, as you can see. But you can also connect up and have storage running in the cloud in like S3 or various places like that. And you can also, just because these are all part of one cluster, it doesn't mean they have to all be located in the same place. You can have elements of the control plane running in separate places. So when your data center in Germany burns down, it's not the end of the world. You just lost part of your cluster. So some terms here, cluster, it's the nodes that the apps run on. The controller manages the state. The manifest file will be either a JSON or YAML file that basically tells Kubernetes what you want to do. You can delete things, you can add things, you can remove things, etc. Pods are basically the base group of containers that you're running together. And by default, if you're inside the pod, you can see each other. If you're outside the pod, you can't. Volumes are just basically disk directories that you can store files in. Workload, they're tasks. So think of like cron jobs, servers, daemons, etc. And kubectl or KUBECTL is the command line tool that lets you create things, check on the state, update, delete. All of the configuration goes through that. Are you confused yet? I know I am. So the easier state than rolling your own, there's a distro called Minikube, and it's fairly lightweight. You only need 2 gigs of RAM, 2 CPUs at the minimum, 20 gigs of free space, and a internet connection. But that's still pretty darn heavy. I know it's going to be a struggle to get it to run on my Raspberry Pi here. The good news is Rancher has an even slimmer container Kubernetes cluster that's meant for like edge computing and ARM and all the easy parts. And its name is K3S. Why K3S instead of K8S? Well, because it's 5 less than K8S. That's the actual reason. There is no bigger name to it than that. Apparently, the salespeople at Rancher absolutely hate the engineers for naming this. But basically, it's just Kubernetes, only the good parts. They stripped out all the stuff that you aren't going to use anyway, because Kubernetes is huge. It's about a 40 megabit or megabyte binary. You can run it on essentially a toaster if you want. And if you want to install it, it's real easy. You just copy and paste this curl command and pipe it into SH, and you're good to go. 30 seconds later, well, depending on the speed of your internet, 30 seconds later, you'll be done. Of course, the standard disclaimer, copy and pasting stuff from the internet and just running it all willy-nilly is kind of risky, but hey, YOLO, let's go for it. And so, as you can see, it's taken that huge sort of architecture, and they've replaced some parts. So the database is being handled by SQLite, and there's some networking stuff that's being backed by something called Flannel. And so it's basically, and then it's leveraging Containerd for the Docker parts of it. So as you can see, it's a lot simpler and a lot lighter. Or the final option, which is fairly easy, if you have Docker Desktop in Windows, you just check the box that says Enable Kubernetes and it will spin it up. I know this is a Linux users group, but it uses WSL2 under the hood, so whatever. The last final thing that I'm going to show tonight is Helm. And basically think of it as sort of like how Docker has containers that you can download from the internet. Helm is for Kubernetes, where you say, hey, I want to have a WordPress blog. Give me a WordPress blog. And then it has all of the instructions in there to spin up a MySQL database, a Apache server, a Kafka, whatever, for logging, all of the various pieces that you need. Someone's already done the work of wiring them all together, and basically you have the option of either you can roll your own from scratch, you can package into archives, or you can sort of install and remove pre-baked ones. And to install it, again, you can easily just copy and paste this command and pipe it through Bash, and it will install itself on your cluster. So we're to the point where the metal hits the road here, and we can actually start playing inside of a cluster here. So I've got my cheat sheet here. And so basically to install Kubernetes, or if you want to update it for K3S, it's the same exact process here. You just copy and paste this getk3s.io and pipe it through SH. Type in your super secret password. And then it runs and installs, creates a couple symlinks, and there you go. So after we give it a second for it to spin up, which nothing actually happened because I already did this last night, we can ask, okay, what are the nodes? What machines are they running? And we can see localhost, this one machine's the only one that's running. It's been up for 19 hours, and it's both the control plane and running as the master here as well. So it is a cluster of one. So if we want to just spin up and create a node here, the command we have here is basically kube control, which is that command executable, and we're asking it to create a deployment, which is basically going to stand up a pod that's named hello node, and in that pod there'll be a container that is this echo server. So nothing really complicated. Basically all it is that we'll call it, and it will return back just exactly what you asked for. Hey, we just created it. It's easy enough. So now if we ask, okay, what pods are currently running on the cluster, we can see that this hello node is up, and since it was so small and simple, it's already running. This 1 out of 1 indicates that there's one replication of it. We could spin up multiple ones and then load balance and etc. That's way out of the scope for this presentation. And we can also see just exactly what happened under the hood. Get events will tell us, okay, what did it do to get to this point? And you can see that it scaled up to 1 out of 1 and created the pod, etc. Pulled down the image, created the container, and started it. If something failed, we'd see it there. And we can also see this, basically the config file that it ended up creating under the hood. So you can see it created a server. Here it's running on localhost at that port, which that's the localhost of the container itself. And that there's really not much to see here. It's fairly boring and standard. Okay, so it's inside the container, inside our pod. It can't get out to the world. If we want to expose it, basically we have to say, hey, we want to expose it. We want it to be a load balancer type, so that we can get to it from the internet. and it should be exposed on port 8080. Tells us it's exposed here. So if we go to localhost 8080, here it just responded to us and said, this is what you sent me. Fairly simple and standard. And so we can see, okay, just exactly what did we expose out to the internet here. And you can see that we've got it exposed to the load balancer. Internally, it's 1043.01. And externally, it's this 10.00.125 exposed on port 8080. Again, nothing very exciting. This is just as stupid and simple as you can possibly get. Well, now that we set it up, let's go ahead and tear it back down again. And basically the verb you need to know here is delete. And we want to delete the service that we created first, and then the deployment. Again, nothing very exciting here. So then the next thing that we'd want to look at here is we don't want to do this all by command prompt. We want to have it reproducible. So you can create a YAML file that basically sets up, and this just stands up a simple Nginx server, shares some files, and etc. Nothing very exciting here, and the name of it's shell demo. So if we want to deploy it, you just run this apply, and in that, if you told it to delete things, it would delete it, etc. It basically just does everything that you tell it to do in this YAML file. There we can see it was created. Let's go ahead and verify that it's running again with the get pod command. And you can see it's running. Again, it's just simple, and I've already run it before on this machine, so it didn't take very long. Now, let's say we actually want access inside the machine. Just like you can do with Docker, you can connect to the actual container and run things interactively. And in here, the verb that you care about is execute here. And then you have that you want to connect up to the standard in, and you want it to be the shell command or the shell demo container, and you want it to run bin bash because otherwise it's not going to be very exciting. So in here we can see that we're actually inside of the container, and we're running as root, etc. And at this point, you could do whatever you want inside this container. And I mean, you can do all sorts of very bad things in here, but the good news is it's within a container, so you're really only hurting yourself inside there. So as you can see now, because I rm-rd, you can't even delete or you can't even run ls because that executable doesn't exist anymore. So let's exit back out of it because we've totally hosed that container now. And when it's time to clean up, we just delete it the same way with delete pod and the name of the pod. And there we go. So the one big thing I had to do to make this work right was setting up this kube config to make sure that kube control actually could find my container, because Rancher puts it in an odd spot. So if we want to run helm, basically I'll go ahead and skip over actually copying and pasting these in because I've already set this part up. But if you run helm repo update, it will pull down the latest copy of your helm containers that you have, or your helm repositories that you have set up. And then you can install a few things. And if there's a new chart repo that you want to add in that you don't have current access to, you can go ahead and just run this repo add force update. And you can see there it added it to its to your repo. And if you're looking for containers that or charts that you want to install from, for example, here at the Bitnami website here, you can see all sorts of different containers that you can leverage, whether it be WordPress, Joomla, Drupal, etc., GitLab, Ruby. I mean, you name it, they have it here. So if we want to run DocuWiki to run some documentation, it's fairly easy here. This really isn't the, sorry here. Here's artifact.io is the one that is like Docker Hub. So like say if we wanted to install Postgres here, you add the repo Bitnami if you haven't done it already. And then to install your Helm, it's just as easy as copying and pasting Helm install and your container. And this is where I was talking about where if you see this error that it was unreachable, connection refused, that means your environment isn't quite set up right. So I have to add in this export kube config. And now if we try it again, there you see, if we look here, it says that it, let's see here. So it released it, it deployed it, and now it's spinning it up. And you can figure out what your password is here and various stuff like that and connect in. So if we run this, let's see here, looking back at our cheat sheet here, if we take a look at this get pods, it will list what's currently running, which is our Postgres, and you can see it's running up, it's up and running. You can also check and see what actually happened with this command here. And you can actually see the standard out and standard error of your container as well. So you can debug and see that it spun up and worked. And the other big thing that you can call out here is that you can actually use Helm to create actually a chart. And in there you can set things like the values and basically create your own charts. That you could spend a whole nother talk on that topic, however, unfortunately here. And this is sort of like how you can create your Docker Compose-esque sort of setup. If you have a Docker Compose that already exists, there's a application called Compose. I know it's great spelling, and it will actually, it's a tool from OpenShift that will basically let you convert your Docker Compose files into a Kubernetes copy. And basically you just have to download it from GitHub and then give it executable rights, and then you just basically run it. And basically you just run compose convert, and it will create the YAML files that you need to deploy to Kubernetes. So in this case, our Docker Compose has a couple Redis, it has a Redis master, a couple of Redis slaves, and then a front end server, and then stands up a load balancer basically. So if we want to create them, it just is as simple as, so here we go, compose.
Andrew, quick question.
Yes.
Was Redis some sort of repositories, or is that what?
Redis is a in-memory caching server. So basically, it's with a lot of hand waving here, it's a key value store that if I hand you something and tell you it's Bob, when I come back and ask for it again, if it hasn't expired, you hand me back the thing I handed to you when I say the word Bob, if that makes sense.
You can think of it kind of like a password cache or something like that.
Yeah, think of it as like usually one of the ways that it's used is it costs a lot of time and expense to download data from the database to find what school your kid goes to or something like that. Well, you look it up once and then you store it in memory, and it's real fast if you want to look at it again. Or like say if you want to keep state across multiple web servers that are all serving up the same web application, you set up that state with cookie with like a GUID or a unique ID, and each time you visit the website, no matter which server you're on, they all hit that same cache and serve out the same thing, basically, if that makes sense.
So you're saying it's distributed, or it's a central store somewhere, or?
So it can be both. In its base case, it's one machine running, but you can also have a cluster of them, and it shards the data across the whole cluster. So that if you're, think of it as like a phone book. So if you're talking to the phone numbers that are in St. Louis, that goes to one server, New York's on a different one.
Yeah, no, I was just thinking about how to keep it synchronized between nodes.
It magically handles that for you. Basically, through sharding, I believe it also does keep, you can have where it's across the cluster and it's eventually consistent, or I mean, there's a lot of knobs that you can turn there. That could be a whole nother presentation in and of itself of how to handle that. In most cases that I've ever used it, I've never been you need more than one node though of it, just because it's in memory and it's super fast.
Okay, thanks.
But so if I wanted to basically convert this Docker Compose file that I have, you just go compose, convert Docker Compose.yaml, or just convert. Yeah, okay, just convert it. It knows that you're looking for Docker Compose.yaml. I think you could have -f and name the file. But as you can see, it spun up a set of different commands here that you can run your kubectl to actually deploy them then. So when it comes time to apply it, you just run kubectl -f is the name of the file, and basically you just feed it a comma separated set of files here for it to deploy. There we go. And now if we run that same command of get pods, we can see that it spun up a front, or well, it's still creating it here, a front end container, and then now it's running. And if you ever run into wondering just exactly what is all on here, you can do API resources. And that gives you all of the information about everything that's running on this machine. As you can see, it's quite complicated.
Okay, so let me expand that for a second, since don't have any other questions. Let's say I've got 5 disparate workloads, you know, name servers, email servers, MTAs, MUAs, and
Yep.
I've got two clusters, 2 Raspberry Pi clusters with 8 Pis in each type of thing. With having 2 clusters would give me some sort of hardware redundancy, which was one of my concerns. So what you're saying is I could run a Helm script for each one of those services and tell it I want. Of course, you got to have, I guess, a master too, of two clusters, 2 nodes, and a master somewhere, and then it would automatically. Go ahead.
So my thought would be on that, rather than having 2 clusters, have one big cluster, and you can actually do. I'm not showing it here because it's pointless to tag tasks on one machine, but you could have, like, say, one's in Des Moines, one's in St. Louis, one set of clusters. You could have the one set of set of machines with the tag St. Louis, and the one in tagged as Des Moines, and you can actually set up and say, hey, I want to run 2 replications of this mail server, and have one running in Des Moines, one running in St. Louis. Or, hey, I want to have one instance of it. Well, if you have 2 master nodes, one in St. Louis, one in Des Moines, if St. Louis gets hit by a meteor and isn't there anymore, well, everything will transition over and launch in Des Moines instead.
Okay, so how do you handle the routing at that point? You know, because you've got 2 clusters on 2 totally separate networks.
Yep. The way that you can handle that is there's DNS configurations that you can set up, so that basically as soon as you have a real short DNS time to live on it, and it will fall over to your endpoint. Also, another option is that you can configure that sort of load balancer option that you saw me use. You can actually set it up so that there's a load balancer in both locations, and then you serve up DNS in a way that you'll get whichever one's closer, and then it will automatically remove it from from contention if it disappears, basically.
Okay. Okay. So basically half a step back. My mental image of, you know, geographically dispersed clusters was to give you a way of routing traffic to the closest user. In other words, if you get a request from the East Coast, you route it to Kentucky. If you get a request on the West Coast, you route it to Wyoming or whatever.
Yep.
But what I'm saying is, I don't care about diversity. I just want more. I just don't want a single hardware point of failure, except possibly for your outbound link.
Yeah, and in this case, basically, so there's 2 different ways that you can handle it, where you can set up tags to say, hey, I want 1 copy of each of these servers to be running in each geographic location that you're at. And that way you get the local copy of it, and then you can handle however you do sharing across that's an application level problem, or they can all have shared file system, or whatever magic you're doing there. But you can also have it where if there's only 1 copy of it running and it's in St. Louis, and you end up hitting the Idaho load balancer, it actually will route it through because the network, the clusters all networked together. That's what that flannel application's doing, is taking care of sharing and rerouting where you're going. So you hit, and in theory, you have a fast network connection between your various locations, it will route it across and connect you to the right spot. So in the basic case, you don't need to worry about what machine it's running on. The cluster takes care of that for you, if that makes sense.
Okay. Okay, thanks a lot.
So that's one of those things where you can get just as absolutely complicated as you want, and that's going way far above and beyond what I know how to set up without reading up on it. Because at the moment, most of my work is being done on a 3 or 4 node cluster at the moment, or it's being handled by someone else set up that part of it, and it's running in Amazon's EKS cluster. And at that point, networking is magic, and I just don't have to worry about it. If that makes sense.
Yeah, I'm in process of digesting. I'm still trying to wrap my mind around it's a little bit off topic, but basically I've got name servers, mail servers, both MTAs and MUAs, web servers, application servers here in the shop. And I'm trying to move the cheap hardware. Okay, so I got half a dozen of them on Pies right now, which works great. But then I've got 5 or 6 individual pieces of hardware to manage updates on. And if one piece of hardware fails, that function goes away. So I think a cluster is the way to add resiliency to that. But in this case, I'm just making sure that, say, I've got 3 node Pi clusters. You know, that's 12 CPUs, 12 gig of RAM, or with the new Pi 4 or whatever, or even Odroid. But I'm trying to wrap my mind around a picture where I can get resiliency and redundancy, but I don't care about geographic diversity. Does that make any sense?
Yeah, so there are highly available topologies that you can set up where where you have multiple machines in that control plane, where they're all shared together. So if even if you lose one of your control plane machines, it basically will be resilient enough to come back.
Okay.
So here, let me hit.
Is that something that is part of Helm and or Rancher, or?
So Rancher totally can do it. But basically the idea is that you have all of these worker nodes that you could have 20 of them. And in this case, you have 3 control plane nodes. So even if you lose, I think like 2 of them, you're still okay. And so you just keep throwing more nodes at the problem, basically, and hardware ends up being the solution to your problem.
Okay, so in that case, how do you handle your persistent storage, your persistent volumes?
So that becomes a little bit of a bigger heartburn. Your persistent storage, one of the easier options is setting up like a persistent storage in S3 or something like that, and punting to Amazon.
Or how about NFS?
But NFS would be another option. But so with Kubernetes or K3S here, basically you can have multiple servers and then agent nodes, and basically there are ways of here's high availability with external database. So you have multiple servers, multiple agents, and networking, all inter-networked together, basically. If that makes sense.
Okay.
Lee, I don't know if you've been. I can put you in contact with. Drawing a blank on his actual name. His handle on IRC is Dago Red. Will.
Oh, yeah. Yeah, I know
is
he's on Slack. Too.
yep. He would be the perfect one to ask how to actually really set this up, because he actually has a Raspberry Pi Kubernetes distribution called Buzzcrate, and if you get him wound up and start him talking about it, you'll lose several hours.
Okay.
But in a good way.
Yeah, I appreciate the distraction. I don't want to take any more time from the presentation, though.
So I think we were pretty much getting real close to the end of the presentation here. If people have other questions here, I'll do my best to answer them.
I have a question there, Andrew.
Yes.
Early on, you mentioned with the nodes and the pods, right? And you said, okay, well, you could have like a pod and it could have several nodes in it, right? And within the pod itself, the nodes can talk to each other. I think
Yeah.
you said
So
that.
let me pull back up the.
Don't do it for me because I can't see. So, but you can pull it up for everybody else.
That way I can get the terminology right here, because I apologize. I'm terrible about terminology here. So let me hit screen share here. So spinning through, too far. Cluster is a set of machines. Basically, think of it as the cloud of machines that you could run stuff on. In there, pods are basically your base unit of work. In there, inside of each pod, you have containers, which are your Docker containers. And so you say, hey, give me a Apache server and a MySQL server and a mail server. And they're all running inside of this pod, and they can see each other because they're within the pod. But by default, no one else outside of the pod can see it. So I can have my pod running, Lee can have his pod running, he can have 3 other pods that he's running for his clients, and there's no worry about collision or having contention or disagreements or fighting for resources or stuff like that, because I can define and say, hey, my Apache server, I need to have at least a gig of RAM. And you can reserve that and say, okay, this gig of RAM, it's mine. And then Kubernetes will schedule where it can actually run. Or you can say, hey, I need to have port 8080 available. And it will schedule it to run on a machine that has 8080 running, which was one of the big heartburns that I ran into running it on this machine here for trying to do demos. The first one I tried to spin up because it would be cool and great to show you guys WordPress. Well, port 80 is already being taken by the some of the management stuff inside of K3S. So by default, the Helm script to spin up a WordPress site just absolutely would spin up to the point where it was trying to schedule a load balancer, and it said, well, sorry guys, I can't do anything, port 80 is taken. So that was one minor hiccup that I ran into on that, which I don't normally see because I'm really not in the, I don't normally spin up a WordPress site just for the heck of it on my local machine, because I mean, no one reads my blog anyway. But if it's running on localhost, definitely no one's going to read it.
Okay, yeah, well, that answers part of the question. So the pod is a unit of work. We're currently working on a Docker system that has a Ruby on Rails in one container, MySQL in another container, and then there's a thing called Docker Network, which confused me, but apparently that's something that Docker Compose sets up for you automatically, I guess, or you can name it individually, I guess, inside the YAML file. But anyway, you have to set that up first, and then you have to set up the MySQL to talk to, and then the Rails server. They all have to know about that same network, right? So then, so they would all be in a single pod. I get that. But my second part of the question was, okay, if there's multiple pods, is it possible for one pod, I don't know, let's say you had like a local copy of S3 running, like your own version of S3, right? Running in a pod or something. Could the pods be configured to see each other, right? Like, just say, okay, here's an IP address and just go for it.
Yes, it is possible to do. I'm pretty sure here. Rapid fire Googling here. But yes, there are ways of connecting together two pods. Let's see. One of the easier ways is by using the command expose. So cuddle expose and the name of the pod. Basically, you can open up. Here, I can hit.
Can you give it like an IP address and a port or something as well?
Yes. So one of the first things I did during my demo was actually expose out to the public that Echo server. And so if you'd been on my home network here from another machine, you could actually have gone to the IP address of my actual machine here and hit port 8080, and from inside of Kubernetes, it was serving out the actual service.
Right, that's a little bit. Docker Compose does that too, right? So you can say,
yeah,
you want to expose this as whatever port. But here's the other question. So the if the two pods, let's say for example, you had the one pod was just like a little worker bee that was just serving up S3 buckets or something, and you had like a couple of other pods that were completely different, but they needed to talk to it. Does Kubernetes like manage that? So for example, my point is, like, say for example you had one of those pods and then you had like another one was kind of like a backup or a redundant one, or could be a resilient one like you were talking about. Like, so in other words, if the two other pods are talking to that S3 bucket thing, right, and the S3 bucket host went down, right, did the other one spin up, or would that handle that within Kubernetes?
Yes.
Is what I'm saying.
Yep, it will spin it up, and then also the way that you communicate between different containers is all via DNS, sort of the same way that you do in Docker Compose. So if you named your web server, DNS will actually, you can set up like round robin. So if there's 3 copies of web server, you'll hit a different one each time, or stuff like that. And you can do the same thing inside of Docker Compose.
Okay, thanks. That answers my question.
Yep. And that also helps with the, if it goes down, well, DNS will redirect you to where it launches in its new case. The one thing to call out though about if it goes down, it launches a new copy of the container. So any state that was happening on that server at or inside that image at the time, if you don't do some sort of thing like checkpointing or some sort of way of saving state, you'll lose it essentially. So that's always a little bit of heartburn there, unless you have like persistent storage or something like that. Any other questions?
Don't be shy, people. It's sometimes tough to wrap our heads around it. I mean,
There is an awful lot there.
Stan, you got something, or Dave?
No, I was trying to formulate something, but I got nothing.
This whole area of and I appreciate it. I forget the gentleman who was speaking at CIALUG last night, but the main speaker, he started out by giving a little bit of history, and he went back and talked about, well, as soon as we had electronic computers, there was the mainframe, and you had to go with the deck of cards in your hand, and then there were terminals, and you could actually, wire that terminal out, to the next room or the next building but I always appreciate that there's yin and yang of, in the old days, everything ran on that machine, and now we call that machine the cloud. And it's kind of like everything is, he was pointing out that history was coming around again, and I agree with him. I think we are kind of coming back to, it's new terminology and new ways of doing it, but the same basic philosophy. We all got to learn how to put stuff back out there on that on the cloud.
Yeah, the gentleman's name was Brian Mullen. He's actually out of Raleigh, North Carolina.
I disagree, Gary. Even though everything ran on that big machine, there was a big machine at your university and a big machine at my university, and they were separate and different. And within that big machine, everybody had one login. In the cloud, no, there's one cloud. There's only one cloud. Everybody's got different logins. There's no synchronization in the cloud. I don't think there's any similarity at all.
Oh, wow. Okay.
Yeah, but those universities were connected by a BitNet, which is a great acronym, because it's there.
No, I'm talking about before that. I'm talking about before the connectivity. Maybe, connected, I wasn't aware of it. We had a controlled data in the big machine, and then we had a bunch of little PDPs and VAXs, and they were a little bit more connected. But the big controlled data with the card readers and the terminals, the Hazeltine terminals, it was all standalone.
Mm-hmm.
Oh, if it was at a university, I'll bet you it was on one of the nodes on BitNet, because they hooked them all up by leased lines going at about 9,600 baud. So,
what kind of information would they trade over BitNet?
Well, BitNet was quite a bit primitive to what we would call the internet today. So think of it more like UUCP and CU, if you remember those guys, right? It was like point-to-point file transfer and remote logon.
ASCII art and calendars and pornography.
Yeah, don't get me started on that.
Well, but it wasn't even email, right?
Oh yeah, they had email too. Yeah, but email was storing forward, right? So it was basically they had like an address or whatever, and if you were sending it cross country or over to England or something, it would go, point to point to point, and then it says, oh, I got to move it over there.
Well, even if they were connected, that's just Al Gore's internet. It is not the cloud. I'm not even sure what the definition of the cloud is.
That's because there isn't one, Stanford.
There is no.
Yeah, go ahead, Andrew.
There is no cloud. It's just someone else's computer.
Right.
Yeah, really.
Yeah, cloud, I mean, that's fine. It's kind of a, the cloud is kind of a, what I want to say, a meta frame or whatever. It's a, it's a design architecture.
No. Andrew said it, Stanford. There's only one definition of the cloud: somebody else's machine. It can be owned by Amazon, Google, CenturyLink, and 1,000 other players. It could be a VM in DigitalOcean. Technically, that's the cloud. Although
No, I think you're right. I think I'm gonna have to think about that definition. There's your machine and there's somebody else's machine, and
Right.
that's it.
that's it.
And because the cloud is not, it's some multiple body else's machines as plurals, right?
Yeah, so like say with S3, I don't need to know where it's stored or what machine it's on or etc. I just know that I hand Amazon this pile of data, and when I ask for it, I hand it back. And I also have to hand them a pile of money as well.
Could somebody explain what an Amazon S3 bucket is for a guy who doesn't really know yet?
S3 is just a storage bin, basically, that an object store. So you say, I have object foo, and in it is these 10 gigabytes of data. And when I ask for foo again, I get back that object.
And you buy it from Amazon?
You pay for it by the gigabyte, as well as every time you access it.
Yeah, if you're kind of renting the storage.
But the good news is it's stored in triplicate.
Turn it off when you don't use it. Right?
Yes, and you can also set retention policies and say like, hey, this data, I don't want to see it ever again unless the world ends. So go ahead and store it on tape. I'll wait for you to restore it when I need it back again.
So you're talking about the Glacier?
Yes.
Which makes it's very cheap using Glacier. It's just you have to be aware that, yes, the next time you want this data back, it's not going to be instantly there. You have to almost
it
like
might
the
take
old
4
days,
hours or
Mount
4
tape.
days.
Yeah. Yeah.
It depends on, you can get it back faster if you really want to, but you're going to pay for it.
But again, this goes to that historical reference, and I Stanford, I really appreciated your slightly different take on it, but I still think of it the same way. Here's a good case, you've got Glacier, which is basically tape backup of your tape storage of your old mainframe data, and my key take was, we'd gotten so much to the point where everybody was running their own either desktop or laptop machine, and it became a thing of, you want that data? Oh, well, that data is on Stanford's laptop, or that data is on Ed's laptop, and now it's no, it's all out there. It's in an S3 bucket, and we just need to give you permission. You can sign into the cloud, run your own thing in Kubernetes, and you can get to the data.
Okay, you're talking about the centralized, decentralized two-step that we continuously do.
Exactly. Yeah.
I'm trying to think of the other metaphor of with dial-up, right? And when you used to download your email and then answer it and then connect up again and re-upload all of your answers.
Yeah.
Right. The centralized versus decentralized.
Mm-hmm. Versus, rather than do the download, type your answers, then upload your answers, do you just use it as a terminal, and you just get a terminal session on the mainframe and answer your mail there? Yeah.
And I think the corollary to centralized and decentralized two-step is connected versus disconnected. because if you're connected all the time and that's not a problem, then centralized is okay. But if there are reasons why you experience periods of disconnected or independent or whatever that means, not on the grid, then that's where decentralized has the advantage. Same thing with GitHub, right? Why don't I download my local repository and then I sync back up with the master GitHub.
The only problem with that is if you don't sync often enough, if you're collaborating with someone, you end up being merge hell.
That's what I'm saying. I mean, there's the two. I think there's just the two paradigms. The centralized, always connected paradigm, and the decentralized, I don't have to be connected. I can be independent and free paradigm.
I think, Gary, I agree with you, your analogy with the cloud and the old mainframe time sharing days. And I was just recently looking at the way that the IBM 3270 terminal worked, right? So it's interesting because like they realized that they had a bandwidth problem, right? And so it says, well, what if we sent, formatted data, think HTML, but it's not really HTML, right? What if we sent that and then let a processor, like an edge device, in this case the 3270 terminal, right, handle all like local edits and all that kind of stuff, right? And when you're ready, there's a big red button on the keyboard that says enter, and then that packages that back up and sends it in a single bucket upstream to a call concentrator, which then sends it over the wire, gets over to the other call concentrator on the other end, muxes it or whatever, and then the mainframe handles it, right? So that's a lot like what we're doing now, right? We've got our own little PCs here, and then we okay, we want to go to a web server. Well, that's kind of what you're doing, right? You got a browser on your computer that's handling all the local interactions, and when you're ready to go, you hit the submit button and off it goes.
Yeah.
Another term that's used an awful lot in sort of IoT computing, where you have multiple sensors across the world all collecting torrents of data all at the same time, is instead of cloud computing, they call it fog computing because it's closer to the ground out at the edge.
Oh, neat. I like the term.
So you do your pre-processing out on the edge. So like say at your local cell tower, that you collect up all the logs and you look for, okay, what's abnormalities that are happening that actually matter versus drinking from the fire hose and having to shovel it all back up to a centralized point.
I like that term. Yeah. Cool. Let me jump back into the modern world and get out of comparison that way. A question about something that was early in your presentation, Andrew. I believe it was the slide right before you mentioned Docker Swarm. I forget what the actual title of the slide was, but it was basically starting to talk about what alternatives there are to Kubernetes. And
Docker Swarm, yeah, there's Docker Compose. Here, let me hit share there.
There we are.
This slide?
Yeah. And so you were saying that it was going to fail because you really liked it, and of course that's the kiss of death.
Oh,
I'm familiar with that. It's my own situation. Anytime I like it, I still don't understand why Betamax didn't make it. Yes, but
yeah, industry standard has been that Docker Swarm, I mean, it still exists Docker, the company Docker, is still trying to push it, but I mean, even they've sort of shrugged and said, yeah, it's really not winning. And part of the reason why it hasn't is because it's simple to set up, but the moment that you get to a complex problem that's beyond what it can handle, you hit the wall and there's nothing you can do. And plus, there's just so much more documentation out there for Kubernetes, and that's the way the world has gone, unfortunately.
Okay, so that's what's killing it, is it's a nice simple way to get things going, but you find yourself stuck. There's not enough flexibility. Okay.
Yeah, it's sort of like you can bake amazing things in a microwave, but the moment you stretch beyond what you can do in a microwave, it really doesn't matter how nice of a microwave you have, it's still not going to be able to do it.
Okay.
If that makes sense, hopefully.
Yeah. And
Gary, what was you were talking about the history of it with the Borg and all that? What's all that about?
So Borg. Borg was Google's internal Kubernetes software. Basically, Kubernetes grew out of Borg when it was sort of, Google's really famous for publishing papers talking about their internal stuff, and then someone goes out and sort of white label recreates it in the open source world.
Are you thinking about MapReduce or something?
Yeah, like MapReduce is another great example of it. That whole technology stack sort of came out of Google talking about big tables. And by my understanding, Kubernetes sort of has similar things where it arose out of Google, and it became, it grew into a beast of its own. But I do know that Google still has rather heavy ties into actually integrating with it and improving it and stuff like that, because just this afternoon, one of their headhunters actually called me, so trying to recruit me to be a SRE or engineer or something like that. But I really don't want to move to California, so that's sort of a non-starter.
Whoa. Yeah. Well,
Plus,
the first thing you have to do is give you 4 times your pay.
Yeah. Plus, honestly, I don't want that kind of stress in my life. It's site reliability for Google. When you have a bad day, it makes the international news.
Ouch.
It's like Microsoft the other day had issues with their single sign-on stuff, and that brought down productivity for the entire world. People noticed and were talking about it. And I really don't want to deal with that kind of hate.
Ed, there was another thing. Stan had posted the reference to Wikipedia's article on Kubernetes, and in there, and I just cut the snippet and sent it out to discuss late this afternoon. But the original code name for Kubernetes within Google was Project 7. And it basically was named after 7 of 9 from Star Trek Voyager, because it was something that was going to be a transformative thing for their Project Borg. So.
Oh, I get the reference, because she was like a former Borg, now fully human.
Mm-hmm. Yep. Yeah. You got it.
Naming things are hard.
What was it? Wasn't Jerry Ryan married to like Illinois governor or something? I can't remember what the deal with that was.
You may have remembered my crazy analysis. Jerry Ryan, his wife, Barack Obama became president of the United States. And the logic to that is she was married to a guy named, what was the name of the hero in the Tom Clancy novels?
Jack Ryan.
Jack Ryan. So her husband was named Jack Ryan, and he was a congressman in Illinois, and he was going to run for the Senate seat. And he looked like the movie star. He just had the movie star looks, the air about him, and he was the odds-on favorite that he was going to win. And especially when a black man was nominated from the other party, and so yeah, obviously Jack Ryan was going to win, and it turns out that she filed for divorce, and in the divorce settlement, they got into some of his sexual picadillos, like he liked taking her to strip clubs and saying, "Why don't we have a three-way with the girl over there?" And so his squeaky clean image kind of got tarnished right before the election, and with that, Barack Obama got the Senate seat, and the rest is history.
So it all goes back to Star Trek.
It all goes back to Star Trek. It always does.
There for a while, wasn't the joke about Illinois governors where they were always two-term governors? The first term was in office, and then the second term was in jail.
That sounds about right. Wasn't Rob Blagojevich or something? He went to jail.
I think at one time the state of Illinois had 3 former governors in prison at the same time. They could just call a wing of the prison is called the governor's retirement home. Anyway, back to Kubernetes. So you'd also mentioned Kubernetes Compose. Now that was different. How?
So you're probably thinking of Docker Compose, which Docker Compose is basically a layer on top of Docker where you can say, hey, Docker, set me up a web server and a database and a email server and a et cetera, and make sure that the email server can talk to the web server, but not the database server, and sort of orchestrate that sort of standing up everything all at the same time. And if one of them dies, it will start it back up again, and all those sort of things. But the problem is, by default, you're still running on one Docker machine. And if that machine dies, you're out of luck. Sort of the analog to that is in Kubernetes, there's that Helm program that will let you do that same level of orchestration, saying, hey, I want this and this and this and this, and put them all together for me, and set up networking to do that, and all of those things. And it has the added benefit of people have pre-built what they call charts, which are those sort of Docker Compose files that say, hey, I want to stand up my own WordPress blog. And well, under the hood, it stands up it knows already how to stand up all those things. And then also stands up the network routing and all the stuff around that to make it work.
Okay.
You can still do the same thing in Kubernetes without Helm. But you have to orchestrate that. You have to write that file, that YAML file yourself.
Okay.
That gives the instructions on what it needs to spin up, which you still kind of have to do in Docker Compose as well.
Okay. So as you said in the as you said there early in your presentation, yes, there are things other than Kubernetes, but right now, the way the industry is going, Kubernetes is becoming more and more of this is just the way it's done.
Yes. But the other risk that you have with Kubernetes, there's a lot of places that spend a lot of time and a lot of money standing up their own cluster and hand rolling and customizing it and going through a lot of work. And losing a lot of hours for that. But the biggest benefit to it is I can stand up a Kubernetes cluster in Amazon's cloud. I can stand up one in Microsoft's cloud, in Google's cloud, on-premise, etc. And the work that I do to stand up stuff inside of it, it doesn't matter where it's located. It's the same thing. So you don't have to worry about vendor lock-in.
Okay. Which is a very important thing.
Yeah, it's one of those things like I absolutely love, Amazon has something called Lambdas, which basically you just hand them a piece of code and say, hey, when I call you, run this and give me the results. I don't care what machine you run it on, you deal with all that. But it also means that you're locked into Amazon's flavor of it. And if you want to move over to, like, say, Azure's sort of thing, you have to completely refactor your code to play nice with their stuff instead. And same thing with Google, where you can run it inside of a Kubernetes cluster, and a horse is a horse, of course.
Of course. And no one can talk to the horse, of course. And for those of you who don't remember it, those are the words to the theme song of Mr. Ed, the TV show.
Don't I know it?
Well, I'm sorry.
Let's see. Any other questions, comments?
Snide remarks.
Well, Gary's quoting Mr. Ed, but I was reading some web page today, and the guy writing it is, again, making these historical references. You try scrubbing it out and soaking it out, and yet you still get... Nobody remembers the tagline, huh? Ring around the collar.
Oh.
And like, who's gonna, what young kid on the internet's gonna remember that reference?
Oh.
I think he
Man, and
was
I left out where's the beef?
Oh, wow. Okay.
I heard a discussion today. They were talking about we're losing culture, and I got to thinking, like, oh, like in World War II, that, you know, when the Battle of the Bulge, when they had those Germans impersonating MPs, they started asking everybody baseball scores and team players and things like that. It's because baseball was the American culture that a lot of the Germans didn't know, even though they could speak perfect English.
Ah,
So,
yes.
yeah, and so, you know, at one time, I was talking to somebody that was stationed in Europe, and this was way before the internet, and they wanted recordings of TV shows with the commercials left in because they missed the commercials, of all things. Can you believe that?
I used to have a whole bunch of old National Geographics. You know, they were from like the 1920s and things. The best part about them was the ads in them.
Oh, yeah.
Well, the old Sears and Roebuck catalog from way back then was amazing. You know, that's where my uncle bought his $12 shotgun. Today it'd be worth about $8,000.
Mm-hmm. I have an old Sears single shot. My son always takes it to turkey shoots and things. It's got a long barrel and a full choke, and it puts them all in one spot. It ain't hardly a scatter gun anymore.
Yeah. Well, this was a double-barreled
You know, you're
Shot.
talking about advertising and the Sears Roebuck and National Geographic, and I've gone on and on about jingles and stuff like that. Because you're right, in those days there was the ads were as entertaining as the show you were watching or the magazine you bought. But how many of you are watch YouTube and then it's interrupted? You have a 3-minute YouTube video that's interrupted by this 55-minute infomercial. I don't think any of the ads that I see on the internet are, you know, clever or charming or witty or whatever. They're all annoying.
That's because you're older.
No, they've lost the ability to do witty things. You look at some of the old commercials, even in some of the Super Bowl stuff way back when. It was really entertaining. Those are the ones that go viral because entertainment is so rare now.
I'm really enjoying this discussion. And as we always say, in the good old days when we were at the pizza restaurant, we'd be sipping a beverage and chomping down on salads and anchovies and pizza. But for those who have other places to go and things to do, let me redirect this back to technical topics. And then when we're sure we're done with all that, we can get bound to chit-chatting about other things. But technical topics, both anything specific to tonight's talk, Kubernetes, and if not that, any other technical computer and network type stuff that anyone wants to bring up.
I would say that I have not been paying that much attention to Kubernetes, but the statement that you can run it on Azure and S3 and anywhere kind of, that's thrown me for a loop. So that's
one of the bigger distributions I've heard of. Actually, Chick-fil-A has a set of Intel NUCs at each of their restaurants that are running their back of house software. And so like the stuff that monitors, okay, when do we need to fire the next batch of French fries, or do we need to perform preventative maintenance on the grill top or stuff like that? Each of their restaurants actually has their own Kubernetes cluster that they then roll out software to from the main office.
I mean the kind of stuff that the cook at Steak and Shake used to do by heart.
Yeah, except for more predictably.
Hey, Andrew, as long as the discussion's dying, you given it more thought to hybrid meetings yet?
So yeah, I'm kind of waiting on that hardware that you'd recommended, and going to see how setting that sort of stuff up works. One of the bigger question marks always comes with finding a spot to host the meeting that actually has a fast enough internet connection to be reliable, and making sure that if the person who's presenting is remote actually has a good enough connection to be able to make the meeting work without dying in the middle of it.
Okay.
But so that's something that as here within the next month, the hardware I ordered should be arriving, and I should be able to start proof of concept testing it. And I mean, I don't see us going back to truly in-person meetings for at least a couple more months. And then even then it's one of the big problems I'm struggling with is by golly, we're having just as many people show up to Zoom meetings as we were to the in-person ones. So at what point is it worth the added trouble?
Well,
And that I'm still struggling with what exactly is the right balance.
yeah, I mean, I'm not struggling with it. You know, I see better attendance on Zoom because of physical limitations. You know, I can attend every meeting in Iowa, whereas if it was just in person, for many years I couldn't.
Yeah, I do like the idea of having a hybrid meeting though, if we can make
Right,
it
you can
work
find a location.
right.
Yeah, and from a hardware standpoint, I ordered that HDMI, I forget what they call it, a capture card with a splitter. You know,
Yeah.
basically HDMI to USB, and then HDMI repeater for the projector if you're in a physical meeting. And then I ordered a little 10-inch tablet for $80, or 10-inch LCD HDMI display that I can plug on the side of my laptop to watch the broadcast, and basically share that on whatever platform we have. And then I can either use my laptop for the presentation, or to manage the presentation if I'm doing it, or run Open Switcher if I'm just doing the doing the videography.
Yeah, it's
I'm just
something
going to
that
object for a second so that people have some context. That what Lee and Andrew are talking about was the thread here that was in discuss. I've been meaning to go in and change the title. The title still says library use far off, but they went off on a complete tangent and started talking about, yeah, well, when we finally do get back to meeting in person, can we somehow do a hybrid meeting where we both are speaking to the physical audience and also to the remote audience over Zoom or whatever other platform we're using? So there's all sorts of good technical discussion there about having HDMI capture devices, HDMI splitters, OBS, picture.
Yeah, and Gary, as an overview, the issue is, in a hybrid meeting, you want to be able to see a presentation in good resolution, but you also want the ability for video, like the speaker or the audience. So the big question is, how do you manage two different video feeds, or maybe three if you have two cameras, plus the audio, and get that feed out on whatever you need for the external meeting, for the external audience.
Thank you. That's what I was trying to get to, and I wasn't getting to it.
Yeah, I know historically Des Moines has done where I've just set up like a video camera in the to the side of the room, and we just, okay, well, you weren't able to make it, fine, here's the YouTube video afterwards, posted hours, days later. And I mean, it's better than nothing, but it does lose that interactive nicety.
Right, and that's where I was thinking that you can get a webcam for $10, and maybe have a webcam on a tripod on the crowd, and a webcam pointed at the speaker, so you can have two inset windows with the speaker in the crowd type of thing. And that would give a good experience, and you could either stream it to YouTube, or in fact, that would be another way to do it. Stream it to YouTube and then let the users grab your YouTube channel.
Yep, that's entirely doable. I know you can do it also from Zoom itself, where you can broadcast from Zoom onto YouTube. But I mean, with OBS, you can also have just that OBS output as your webcam into the Zoom meeting as well.
Mm-hmm.
And what does OBS stand for?
Open Broadcast Studio, I think.
Or Open Broadcast System, or Open Broadcast Studio, yeah. It's an open source video switcher product that allows you to combine multiple video feeds.
And the biggest question I have on that is, I'm curious, the hardware that I normally lug to the meeting, I'm wondering how nicely it's going to play with the stresses of doing multiple video streams and stuff like that.
Yeah.
And that's where I'm waiting for the hardware to come on site to actually be able to start playing with that. But I figure I have at least several months before I have to worry about that.
Yeah.
Agreed.
If we're going to worry about this for several months, I'm quite a bit handicapped on being able to hear what people are saying, and I much prefer that you use a speaker view, or I use a speaker view because I read lips, and that way I can see what's going on. I don't know how we got in this particular group to where we say we discourage people having their video cameras on, because all I get is a name and I hear the same burble that I would hear off the radio, which I don't listen to.
Apologies, is this better?
That is much better. And you, by the way, Andrew, have very clear. I can read you even if I didn't have any sound.
So this is a pre-pandemic Logitech webcam that is one of the better ones out there, and also is completely impossible to get at the moment.
Well, in the Zoom, I found that if I use speaker view all the time, every time anybody says anything, it switches to their picture and I can see it. But the way we're set up here, most of the time, all I get is a thing that gives me the name down there, or a sword-bearing dinosaur.
Well, where that came from, Dave, is when we started this, if you turned on too many cameras, there wasn't enough bandwidth to support it.
Is that still the case?
I don't know. I don't have a camera. I gave that Chromebook to my grandson because he was, going to remote school. So I don't have anything with a camera on it. I can't really try it anymore.
I have a question about that. Too many bandwidth to support it. Who's in? At the broadcast end or at your local reception end?
I don't know whether we definitively came to that.
Because I've participated in several different Zoom clubs or whatever. Usually most of the clubs I'm in max out about 25 participants, not into 50 and 100 and 150, 25, 30, something like more like 16 to 25. And yes, if you do gallery view, you can sort of get all 16 or 25 little icons in the Hollywood squares. And then you're right. Then each one of those 25 Hollywood squares is trying to broadcast come into your pipe. And that's huge. What's the size of your pipe?
Well, I've found I can't really use gallery mode, because what happens if you get over 16 or so, you end up having to scroll back and forth to pick up the actual face of the person talking. So it just works better for me to use speaker view, and that's what I really like. It then makes it easier for me to see them. But
that's what I'm saying. If you got a slow pipe coming into your destination and you put it in speaker view, then you should only have one bit stream coming at you, and it shouldn't be a bottleneck.
That's true.
I don't understand. I mean, I remember that day when we said, okay, everybody turn off your camera and see if performance improves, but I don't believe that anymore.
I think things have greatly improved in these last many months, and that goes for whatever video conferencing software you were using. But I do know that Jitsi especially had a very, very bad time of it if you got too many people trying to video stream.
I only had one or two experience with Jitsi with this club. I don't remember it.
Well, you wouldn't be using two video streams. You would be capturing the one display that had the switched video streams on it. Right? That's what I'm thinking.
Oh, for the presentation,
In other words, going over the video conference would be just one screen, which would be presentation plus your inset windows, whatever you do with it. That would only be one video stream. The
one thing
switcher
you
would
can't.
handle the merging before it gets to the video conference.
Yeah, this would be for all of the remote people. So if you had like 50 people on the call and all 50 had their webcams on, is where the concern comes, though.
Oh, you'd have to shut them off. I mean, on Zoom, I got one command, I can kill everybody's video.
Yeah, one thing you can do if you're curious, if you go into the settings menu, there's a statistics tab, and it will tell you exactly how much data you're using in traffic and all that stuff.
No, I never have looked at it very much. My concern has been I get about a 20°C CPU rise when I'm on a video conference, although it's about 10 degrees less now, and I'm assuming that could be because there's only one camera on.
Yeah, like right now I'm using 970K, or well, I'm up to 1 meg now on the send, and receive I'm being burnt 321 KB. Where if people turned on their cameras more, that would start to hurt more then.
Yeah, I'm showing 35K up and 300K down. Now 58 and 250.
Imagine in gallery view, there's probably some video compression, right? Because you don't need to see the entire 1920 by 1080 in that little inset window.
Yeah, it totally is doing that.
Yeah, well, now with 5 videos on, I've got 882 up and 400 down. 800 and something out, now 900 out and 350 in.
Yeah, so my bet is you're sending your full resolution up, and then it's downsizing it for everyone in the gallery view.
Let's see if I turn it off HD. If I turn off HD, yeah, not well. Didn't change the diddle. Still 8 to 900.
Hey Lee, I'm not seeing you in HD.
I just turned it on, or turn it off rather.
Yeah, well, it hasn't been HD.
Now I'm sending HD.
I'm not.
It just
HD.
pulled.
I'm getting lower resolution.
Yeah, I don't know if Zoom will actually put HD on your thumbnail in the gallery.
When you switched in and out of HD, the thumbnail zoomed in and zoomed out.
Yeah, it was just doing clipping is all.
The light makes a difference too,
It's
Andrew.
like that's telephoto or whatever, and that's wide angle.
Huh. It actually looks better when I leave it off.
But yeah, like looking at Gary's picture here, it's definitely lower resolution than what his web camera is capable of doing. They're definitely compressing things quite a bit.
You know, it's funny. I've got gallery view on right now, and I'm looking at Andrew and Lee, and Lee is compressed a whole lot more than Andrew is.
I'm wondering if that's my up, because I have a fairly big pipe here.
No, we got 10 meg up here, and it only shows 300K.
Question, when do we end the recording?
About 10 minutes ago.
Half an hour ago.
Didn't you get the message, Stan?
No.
When the speaker stopped speaking.
Let's see. But hold on, I'm going to try, before we turn off the recording, I'm going to enable my HD. Hold on.
Oh no, please don't.
Yeah, sorry. Hide your eyes. There you go. Okay, now it says I'm in HD. I don't know if that did anything besides annoy people.
No, it didn't. I mean, like I said, Lee was zooming back and forth between telephoto and wide angle, and yours didn't appear to have any effect at all.
Huh, okay.
Yeah, see, from
And
my
your beard
position,
is still as long as it was.
Lee's video feed didn't. You've got lens flare, Gary. You need to clean your lens.
Okay.
I've got what?
He's got lens flare. When you have a light, somehow you got light shining into your lens. I mean, I don't see a bulb, but the lens has somehow got dirt on it, and so the picture is flaring. It's not
Which one's
bad, but it looks like I'm looking through fog, and
Steve,
I've
which
had
one
a
is
lens
this?
flare long enough.
Gotcha.
Steve, which one? Gary? You're saying it was Gary?
That's
Yes.
Gary. See, it's the thing. The pictures are quite different. Lee, you don't
Yeah,
have any pixels. Your beard has got like 4 pixels, and Gary
Mine
seems
or
to have
Gary?
plenty of pixels, but he's in a fog, which is probably a dirty lens somewhere.
Yeah, it's from all that sticky black tape he puts over it.
Oh, is that what it is?
So the other thing about the hybrid meeting, kind of like what Dave was saying, is when you have in the main room where there's one speaker and a bunch of listeners, there's only one microphone. I mean, the cool thing about doing Zoom the way we do it right now is that everybody's got their own microphone.
Yeah, that Stanford, that's a different issue. We almost have to go to at least one wireless mic and one, that the speaker can have, plus one that can be carried around. So audio issue is TBD at this point.
I mean, it's not like we're trying to have a public forum open house about some government bill that's trying to be passed where everybody in the room needs to be heard, because usually it's just the speaker who's speaking. But then when we say, okay, now it's time to open up for questions, then you're right, questions starts popping in from all throughout the room, and you get the standard, can you please repeat the question before you answer it, because I didn't hear it.
Well, most of the ones they use a pass around mic, and they send a mic to it, and I don't know who handles the camera, that the camera sometimes doesn't get them very well. And that was back when we first started other groups talking about. But this particular group most everybody has their cameras off. So all I get is this thing that says it's Stanford or
Right.
whatever. And of course, in my settings, I turn off people who don't have video on my screen, and I just get the audio from them, from people from cell phones and things, where they're just calling.
I haven't tried that, Dave. When you do that, when you remove all the icons that don't have videos, and then one of those icons speaks, where does and this person's speaking now show up in some bottom scroll bar or something?
Yeah, it actually puts Stanford Baldwin down there. And if this was captioned, the captioning for you would be after it, but we don't have captioning here.
Why don't we have captioning?
Because it costs money.
Okay.
I was going to ask that Lee, last week at the Wednesday night meeting, I thought I saw the closed caption button at the bottom of the screen.
There is a button there, but it asks you what service you're going to use to do it.
Okay.
So you either have to nominate somebody to do it, or you have to sign up for a service.
Okay.
Gary, I told you that twice now.
Yes, you did, but the button isn't there tonight. So this is leading into my next question of what happened to the button, even if it wasn't
It's
useful.
changed every time we connect.
Ah.
And not only that, they're different on both of my machines.
Okay.
Okay.
So Gary, part of the reason why you're not seeing that is you are not currently a co-host.
Okay. Okay.
That only appears if you have administrative privs.
I'm going to shut the recordings down now, folks.
Please
Hold
do.
on. In that case, this has been the St. Louis Linux Users Group, the St. Louis LUG. It's Thursday, 18th March, 2021. And tonight's speaker was Andrew Denner from CIALUG in Central Illinois. And he was telling us all about local Kubernetes. And with that,
How
thank
about
you.
Central Iowa?
I'm
Yeah.
sorry, Central Iowa. Dang, I'm stupid. My
Closing
apologies.
comments.
Don't give me an
Thank
opening
you.
like that.
So, all righty. Thank you all for coming. And we're going to turn off the recording now.